Now let's take a look at a couple of different examples, and I think that will help you sort out when something is a function and when it isn't. So our basic rule for what's a function is for every x, there can only be one y. In other words, for every input, it can only have one output. So this first one is a function, and notice I do have some repeats here in the y's, which sometimes confuses people. But when x is -2, the only thing y is 4. Likewise, when x is 2, the only answer to that is y is 4. So for this one, there's no repeats in x. There's repeats in y, but that's okay because for each input, there's just one output. When it's -1, it's only 1. When it's 0, it's only 0. This next one totally throws people because of all those repeated values in the y, but it's still a function because when x is 0, y is 1. When x is 1, y happens to be 1 again, but it's only 1. It's not like 1 and 2 or 1 and 7 or something. When x is 2, it's only that one output, 1. So that's a yes and a yes. This one's our no. So when x is 4, y is 0. But down here when x is 4, then y is 3. So this one, because we have repeats in our x values, that's your heads up that if you have repeated inputs that have different outputs, that's not going to be a function. So you can have all the repeats in y, or the output that you want, that's fine, it can be a function. But if you see a repeat in that x value, which right up there you see there wasn't, that means it's not, or it is a function, because for each x, there's only the one output. Hopefully that made it better and not worse.